Hey, in this video, I really just wanted to add on to what we've been doing when we are graphing in standard form and talk about like now that we can solve the equation, how we take that just one step further. So if this example looks familiar to you, I am taking this from previous work that we've done, and really just giving myself a chance to talk about like, hey, here's how you graph in standard again, and here's how things are different. So I am given a function in standard form. You can assume everything we are doing moving forward is in standard form. What that means is my y-intercept is going to happen at 0, -6. The first thing I need to calculate is my axis of symmetry. That is the opposite of b divided by 2a. In this problem, it is the opposite of +8. That's -8 divided by 2 times -2. I would do my denominator first. 2 times -2 is -4, and -8 divided by -4 is 2. Then how I'd find my vertex is I would plug 2 into my equation. Okay, so that'd be 4, -8, +8, 2. So my vertex is going to happen at 2, 2. Sorry, I'm trying to double check myself in my head. Okay, so just like before, we would look at this and go, okay, cool. There's where my my vertex is. Now, originally, we would just start plugging in numbers. Now that we can factor and solve, you are going to see the test question ask, oh, hey, what are the solutions? I am going to factor and solve this equation. So my problem is -2x squared minus 8x minus 6, plus 8x. I'm going to start by setting this equal to 0. I know in the problem it gives me this in function notation. It says p of x equals. To find my x-intercepts, to find my solutions, you need to know you set that equal to 0. Now, this factoring is going to be a little bit harder than anything you will see in practice or on the test. You are seeing me do this because I chose the first half-decent example I could find. When I go to factor this problem, I have a GCF. I need to remove that GCF, but it also is not going to do anything for me. So that -2 I took out isn't going to help me with anything. For the rest of this problem, I can just forget it. It's not going to help me find the solutions. It's not going to change anything with that. What makes this equation 0 is what's going to make this equation 0. However, once I've removed that GCF, I can go ahead and find my A, B, and C values. And so I'd start by trying to find what numbers multiply to 3 and add to -4. It's -1 and -3. If you are looking at this going, wow, how did he know this? I have a positive number. The only way I get that is 2 positives or 2 negatives. 1 and 3 are both positive, so I could also write -1 and -3. All right, so I have x squared minus 3x minus 1x plus 3. And again, the order in which those two middle terms happen do not matter. right, so my GCF is 1x and 1. What's left over? 1x and 3. My sides would drop down. And so I'm ending up, when I factor this, with x minus 1 and x minus 3. Now that I have that, now I can reset this equal to 0. Woohoo. I'm going to put both of these equations equal to 0. This is what we refer to as ZPP. All right, and what this tells me, my solutions are 1 and 3. That means over here on my graph, my x-intercepts are happening at 1 and 3. Now, this is going to make sense to you because notice they're reflective of each other. Both are one line away from my vertex. They're both at the same point. All right, now, the other point I know, 0, -6. Cool, that means over here, 4 is at -6 as well. Now, previously, we would have to be plugging all these numbers into a calculator. We don't have to do that. Now I can use the axis of symmetry and the reflective property of my graph to find the x-intercepts. I would draw my curve through my points and make sure that I include arrows as the graph goes down. Oh yeah, the graph opens down, it has a max. So as you're looking at this graphing problem, you're going to notice most of it is the same as to what you've been doing. This is by design. The only thing that's new is saying how we find our x-intercepts. As you're practicing this, please let me know if you have any questions, and that's how you would graph in standard form.